yeah, I hope that everything goes well. As Clemens already mentioned, and this is maybe the start of the actual talk, this is kind of an unusual thing, because usually, well, you hear mathematics talks here in this seminar, and this time I wanted to do something quite different. The reason being, I've spent over the last few weeks quite some time on a software package, an animation framework, which also the interns have used over the summer, and I am actually kind of glad that the work started to pay off in some sense, because we have a first stable release of this, or stable release, as you know, software always has bugs, of Manim, and I want to show you a little bit what it can do, and how it can be used. So let me, for the first moment, give you a little bit of a short taste what we can do with Manim, and why I think that it's actually a really great tool for teaching, and also for including like short presentations in short video illustrations in scientific talks as well. The page on the right hand side here is the brand new documentation that we have for Manim. I'll copy the link in all chats that I know. So one here. You can certainly take a look for yourself. And the thing now is, if you look at, for example, the example gallery here, then we can see maybe something impressive to start off strong. Here are some different camera settings. All of this, so you see this is the video rendered by the code piece down here. So you see there is not much code needed in order to create an animation like this. And this is a trend that will well, carry through, I would say. We will a bit later, also in a few minutes, when we are done at taking a very first look at this, we'll just start together and try to set up our first scene and see where all of this leads us and how we can use it ourselves actually. Yeah, so you see there are some different options for text. You can move even the camera around. That's not a problem at all. There are different shapes that you can add. Oh, sorry, I shouldn't cover the thing. Stuff like this is possible without a problem. And actually, again, not too much work to set it up. It's really just a few lines of code. Also here, again, maybe a few more lines, but then there's a nice graph, and you can follow the graph using the camera. Not a problem at all. Well, more fancy examples in the same manner. There are regions you can zoom into your video, which is something sometimes in teaching I would like to precisely do that. You have some situation given, and then I would like to take a small piece of that and zoom in and look how things look in there. And this is also precisely what is possible in yeah, not a too difficult way, I would say. Maybe a little bit of background. Manim is a Python animation framework, so I've sent out some installation links to you previously. And this can be used, or this was created by Free Blue von Braun, Grant Sanderson, someone who is very, very popular in the popular mathematics scene, I would say. Also, he has a YouTube channel which is kind of extremely huge. Maybe I actually show you. Maybe I show you even for a moment, just to give you a taste of because if someone knows how to use Manim, it's the one who created it originally. So let me just give you something, maybe something like that. No thanks. Yes. Let me skip. Oh, advertisement. Sorry. Now I have to play ads on the stream as well. Skip. So you can see that all of the animations here that he creates are very smooth. He even has these little pie creatures that talk to each other and explain stuff. And yeah, I don't want to watch the full video actually, but maybe this animation, because these are kind of neat always if there's some axis or so. Yeah, but anyhow. You might wonder, there is sound currently but not playing for you. You shouldn't have heard anything at least. But this is not so you could theoretically also edit within Manim itself, but it's not really recommended to do so. I would say rather stick to creating the things in post-production. So speaking to the recorded video and then add the sound in a secondary step. Okay, I would say that's everything I want to say for the prelim. Oh, maybe not everything. So the problem with the original version of Manim is that it's a mess. It's really actually quite terrible. It's wonderful. It's a wonderful piece of software. It works really well, but it's terribly documented, and also large parts of it are very, very confusingly written. So what happened over I think starting in the beginning of the year or early this year, a small community formed that started to basically rewrite stuff, document stuff. So all of this that you see here, this documentation here, this didn't exist like say 2 months ago. Yeah. So we have come kind of a long way since then, but there's still kind of a long way to go. Okay, but enough of the uninteresting stuff. Let's start with actually coding. I want to start first with, let me tell you the plan for this. I want to show you off some basic functionality of Manim. So some stuff that you can do really easily that will be possible. That is very straightforward. That doesn't require a lot of internal knowledge of how things work or a lot of knowledge of functions at all that Manim offers. Just going by kind of an intuition thing here, because in some sense many of the basic usage examples that Manim offers, these are very, very intuitive, and I hope at least that I can convince you that they are. And that's what I want to do. So I introduce some concepts, I talk about them a little bit, and I suppose while playing around with that a little bit more on my side, you also have time to check out how things work and yeah. The most important link for this matter is actually the documentation. So if you're trying to find something, try searching it here in the documentation. It's the easiest thing you can do, and it's sometimes helpful. I think this is what I can say for now. It's not in all cases, so not by far not all functions in Manim are well documented, as you will see in. I think if you see, well, I want to see what kind of animations for creation Manim offers, then you would go here and you can already see, well, this is already rather scarce. So there are some function names that you can still read, but there are no detailed descriptions for most of those. So this is it basically that you have to go off of for large parts of the library right now, but we are very actively working on improving that. Okay, so let's start with the first file. I start by creating a file. Let's call it first steps. I put it somewhere. It doesn't really matter where, as long as you have Manim installed. It shouldn't matter at all actually. So I create a new file. Let's call it first steps.py. Maybe one quick question. I use Big Blue Button for that. Can you actually maybe I don't wait a moment. Here. Can you actually read and see things well? Kind of. Okay, I can. There are some steps I can take, but still the recommendation is still if you are having trouble with low frame rate in the Big Blue Button, then switch over to the Twitch stream. I've posted the link like a few lines above in the Big Blue Button chat. Okay, thanks for this. Okay, back to what do we want to see? This one. Okay. And now the first line that you want to usually write in these kind of settings is you want to import the library and the functionalities of the library. For now, I mean, I could do this in a very clean way and only import the functions I actually want to use, but I don't worry about that right now. I want to show you some cool stuff. So let's import everything. And you do it in Python by saying from Manim import asterisk. Okay, that's the very first line. I save this. I hope everything works well so far, and yeah, nothing to show yet. And now let's start with setting up like a first animation, a first little project. I don't know. Let's show how a circle is created, something like that, something very easy. In Manim, all the animations that you write, or if you want to create a video file, basically, you have to set up a so-called scene for it. All the animations are rendered in scenes, and this works by, if you know something about object-oriented programming, then this will make a lot more sense to you. But if not, then don't worry. Just copy what I do. You say class. Then you tell Manim what name your video file basically then should have, or what name this scene should have, and I will use for now, let's say hello world. Then you write inside the parentheses, you write scene with capital S, and then a colon in the end. This means that in object-oriented speak, you create a class which is called hello world, and this inherits from the scene class that Manim provides. Okay, scenes are so kind of the canvas you are drawing on. And what you can have a look now is if you use inside these scenes, there is one special method which will basically be used to go through step by step and do things exactly as you tell it. And then it produces the video out of this method. And this method is called construct. So let's say def construct. For object, this is a class method, so it has to have a self parameter. Self is basically a variable which contains the scene, so you can say if you want to interact with the scene somehow, then you say self dot something and so on. Okay. And now, well, let's see what happens if we do like, I want to have something which I call circ, and in this I want to store a circle. And this circle, let's make it a little bit fancy. I want to have fill color for the circle. Let's put it red, and maybe even some fill opacity. I set it to 0.7. Okay. If I try to render this scene now, if I try to call Manim and say, hey, could you look at this? Could you please produce a video file for that? It will produce an empty file or no file at all. I'm not even sure. Because there's currently no command. We have just created a variable containing the circle, but we've not added it to the scene yet. And in order to do that, we can use self.add, and we put the circle on the scene. Okay, now we actually took the circle from the variable we just created and put it on our screen. In order to actually produce a video, because right now this is done in the very first frame, so nothing happens afterwards. In order to have actually video output that I can show you in a moment, I will use another command, namely self.wait for 1 second. So what I want to do is add the circle on screen and then wait for 1 second, and then loop the and then this should be the video. Okay, this is something now I want to actually render. And how do I do that? I use the command line, and on the command line I use if you've installed the Manim CE package, Python package, then you should have a Manim executable, which you can use in the following way. You first say Manim, then you say the file name, in my case this is first steps, then you say the scene name, which is in this case hello world, And then there are some, I could send this off now and it would render something. For most reasons, however, I like to adapt the quality in which things render a little bit. And in this case, I think it makes sense to change it so that it doesn't produce a full quality, full HD or whatever the default is. I think the default is like high quality, which is 1080p or something like that. I'm not sure, but let's put it in 720p, which is the medium quality, and you can do that by saying -qm, which says quality medium. You could actually, well, don't worry about that too much. Okay, I execute, something happened, and I can look at it, I hope. I will just, this is a bit, so if you use this locally, you can actually, you can actually add also a flag -p, which would just create which means preview, and then it opens the file as well, so you can have a look at it directly. What I will do is, because I'm streaming for all of you, I have to add the video in a different way. So this takes me a moment, but I should have it. In a second. Okay, let's see whether this worked. Yeah, this is the video. There is 1 second of just circle in the middle of a screen flowing around right now. That's it. Because we didn't do anything else, and anything interesting, or let's say that. Of course, I will paste the file that I just wrote into the shared notes, of course. I hope the indentation and stuff is preserved in People button. I'm not sure about that. Okay, very good. I can do that from time to time. Just remind me maybe if I strive off too far again, and then yeah. Okay, so let's make this a little bit more exciting. Let's use actually an animation to show how the circle is created, and not just add it to the scene. If you say self.add, then just the object is pushed onto the screen without any animation. It's just there from 1 second to the other. So especially if I would add another object after this wait thing here, then you would see in a very short blink that there's a second object added. But let's make it a little bit more exciting. So I changed the self.add to something else. Namely, I want to say the scene should play an animation, which is self.play. And then I actually want to say, well, what kind of animation do I want? And this is the point where I've conveniently opened, you don't see that because the video is over there, because I've conveniently opened in the reference manual the section for creation of objects actually. Object stands for a mathematical object, which is the basic building block for everything that you can put on the screen. So I've opened this before. And what you can do with that is you can see what kind of animations you would like to see. The very basic one that I like to use in this kind of context is show creation, but I'll also show you where is it, draw border then fill. So these are the two animations I want to present to you in a moment. Let's see. So what do I do to use them actually? I say self.play, I want to use the show creation animation, and this gets passed as a parameter the object I want to create. So in this case, our circle. Okay, I save the file, I render again, something happened, and now I will, give me a moment again. Okay, and now let's see whether this worked. Yeah. So with this very simple line, we could add the animation to actually create the circle. So this is now what it does is it traces the points of the circle and simultaneously adds the filling. This kind of animation might look weird sometimes because actually you want to this kind of I don't know. It's kind of a weird crossfade, not crossfade, but swipe that you might see, and you might say, well, I don't want that. I just want to trace the line, and then maybe the filling should appear. Well, you're in luck, because there's if we replace the show creation method by something else, namely say by the draw border then fill animation, and then render again, and then I have to change again, like this, then the animation is different. Suddenly you have just the tracing of the outline, and then the filling is added. Okay. At this point, I should maybe say I would have really liked to give this workshop in person, because it's much easier to get a feeling for whether people are trying something or whether people need help than if I sit at home or stand at home and have to rely on reports whether things are working or yeah. So if things don't work, please let me know. We can. It should be a hands-on workshop, so maybe we can try to resolve something quickly. Okay, well, let's continue. We have a first simple animation, namely this funny circle thingy. Let's add some text maybe to it, because text is usually useful. Sorry, before we do that, let's do something different. I'm a bit too fast here, actually. Let's do something different, namely we have the creation of the circle. Let's deconstruct the circle as well. Maybe let's use an animation that removes the circle again, so that this becomes a bit of a cleaner loop that we have here. How would I do that? Well, I first played an animation for creating an object, so there should also be animations for uncreating objects, for destroying objects. And let's have a look whether I can find something. Well, fading is you can't see, sorry. This is a bit confusing for me. Let's hide the video for a moment. In the documentation, there is this in the animation section, so it's right here. Let me paste it everywhere. In this section, there you have the a module fading, and in this module there are several options what kind of fade out you can animate. And let's take, for example, fade out and shift. It's a nice thing, maybe. So what would I do again? I, in this case, add self.play. I add the class fade out and shift that I just copied. And then again, I say, well, the circle now has to disappear again. Okay. Save it. Play it. And I have to show you how does the video look now. Where is it? Here is it. It creates the circle and then it fades out. And that's, well, we have already created a kind of seamless loop which creates circles and then fades them out again. Neat. Any questions so far? Nothing in the chat. More complicated shapes. What kind of shape are you thinking of? I think I see where you're going. No. I'm not sure how well you can combine polygonal structure with arc-like structure. That might be difficult. If you want to do something like that, the best option probably is to create an SVG, so a vector graphic, and then Manim can, to some degree, work with these. SVG import is something that's very hot still, and maybe works in a new version that we are working on and probably releasing beginning of December. But yeah, I can't promise anything, unfortunately. So if you want to work with complicated shapes that you have to actually, that you want to draw and modify yourself somehow, then I recommend using SVGs, so drawing them in like Inkscape in an external program and then importing them into Manim. That works well. But actually, thanks for the pointer, because it would be good to have a second object and not just this little circle here. So let's do the following. Let's wait for, so I want to change the circle like into a square, so that I first one shape and then it gets transformed into the other shape. Let's do that. In order to do that, I say, well, first I create a square. Square equals square. Well, that's easy. Let's add again a fill color. Let's make it blue this time, and a fill opacity. Let's make it also blue. Let's make it also 0.7. Okay. Now I've just again created the variable containing the square, and now the next step I have to do is I have to transform it somehow. So play an animation that changes from one thing into the other, and there's actually a very easy command for that. Namely, we can say self.play. I want an animation. Namely, I want to change the square. Not animation, sorry. A transform, and I want to transform the circle into the square. And then, because the circle is not there anymore on the scene, the fade out and shift should actually not fade out the circle, but actually should fade out the square. Let me maybe paste that into the shared notes. Okay, someone is already doing that. Let me add something here. Version 5 is the standard. Okay. So this is this. I save it. I render it. Okay, something happened. Let's look at the result. And it should be here. Circle. Transformation to the square, and then it. Okay, something is a little bit broken there, it seems. I'm sorry. The fade out doesn't really work in the way it should. But I think this is something that is resolved in a more recent version. You see there is still, well, it has issues here and there. Okay. But the transformation, at least, that worked well. So what's the next step? What can we do? As next thing, I would like to show you a little bit how things can be positioned inside of this screen. Because right now, well, we have added everything to the center of the screen and not and didn't do anything else basically. But let me quickly try if just fading out the square works, or whether we have to fix this another way. Where is it? There it is. Change the file. Save it. Let's see if that's better. Only to some degree. Okay. The issue is probably that within the transformation something is duplicated. And maybe we have to remove the circle actually. That could be it. Let's try this, and if it doesn't work, then well, I'll leave it and create an issue if it's not already fixed. Let's see, this is the new version now. Yeah, okay. The issue is that when transforming, then sometimes shapes are duplicated, and removing one of them with self.remove fixes the issue, kind of. Okay. Well, now let's add like a text above the circle, because that's what we should do. We should label the circle somehow, or at least we should actually put Hello World into it, because that's what you're actually supposed to do with these Hello World programs. To do that, so I want to. This is where the circle is. Let's make this a little bit more structured. Creation of circle, then this is here, then we wait for a while, then we have creation of square, or transformation into square. This is this part here, and then we fade out everything. Okay, so this is just to structure it a little bit more and adding some comments so that things become a little clearer. Text. I would like to add text above the circle. So after it's created, I want to add an animation that writes some text above it. So like if you say the circle is created here, then as a next step, I want to text should be written here. That I want to do. And this is actually, again, easy. I can write t equals text. And this text, let's write hello world. Okay. I usually don't have to specify anything else. So it would be actually good to specify at least a default font, because we're not that great at discovering fonts that are available on the respective system yet, but it chooses something that's kind of appropriate if you don't specify anything. And then we say self.play. For text, the animation I want to use is called write. And I want to write some text. Let's see how that works. I again render the animation. You see now he had to work a little bit more, but this is not very surprising because there are more animations in the scene, and the more animations you add, the more the more things have to be rendered. Let's again properties. Let's see how things changed now. Well, now there is some text animation. So the circle is created, the text is written, and then the square, it's transformed into the square. I've maybe missed some messages. Fade out the circle. Okay. Transform changes the object that you're referencing. So thank you, Andreas. If you use above here, you don't need to actually remove the circle. You just have to fade out the circle. What I do here before, when I play fade out square, is that I first add the square, which is not actually added because, well, it's complicated. Okay. Then this is this. What I would like to do now, or what's a nice thing that we could do now, is the text is not very well aligned, I would say, and it's kind of, it should actually be somewhere else. Let's put it above the circle. So let's try to orient stuff a little bit and move things around. How do we do that? Well, there are several commands that you can call on these objects to align them to each other, to move them, to shift them, and I want to just illustrate maybe a few of them and how they work. The first and the most simple one probably is if you say t.shift. If you say shift, then you can specify a direction in which stuff should be shifted. And at this point, I should maybe also mention that the coordinate system Manim uses has the origin in the center of the screen. So the point 0, 0, 0. So we have a three-dimensional coordinate system. Manim is actually capable of rendering 3D things. The origin is in the center of the scene. Then there is an x-axis going, well, the usual way, and then y-axis also going the usual way. The screen height is fixed to be 8 units, whatever a unit actually is. So whenever you say, if I would shift the circle, say 7 units up, then it would be out of the frame, and that we couldn't see it anymore. So it's important to stay within this bound of 4 up and 4 down from the origin, and the width actually is even weirder because that is fixed at, I've written it down because I actually don't even know it, 14.2 units. So to keep an aspect ratio of 16 to 9, that's the default at least. The width is fixed at, the height is fixed at 8, and the width is fixed at 14.2 units. Why do we need the units? That's a good question. Well, I want to move this now somehow, and the convenient, so Manim offers some convenience constants. You could, of course, just put like a vector here, like if I put the list 1, 1, 0 here, then it would of course work. And let's see how that looks. Everything is rendered. I have to refresh the video. Yeah, now the text shifted like a little bit to up and right, and that's precisely what this t.shift does. The third coordinate is usually just 0, and I recommend leaving that for now, as long as you don't work with 3D animations. So that's shifting in with using a vector explicitly. But what I actually like to do a bit more when playing around with Manim is I like to use the predefined vector constants. So we have constants left, right, up, down, which you can access by simply putting up in capital letters plus, let's say, right in capital letters, and this should produce the same video. Let's see whether it does that. Looks good because it was very fast. It means that it could use a lot of cached data, and and Manim didn't have to render stuff from a new, so the video didn't really change, which is good because I put the same things actually. Okay, so this didn't change anything. Let's see, and now I can also do like, I want to shift it 2 times up and then right. And it's rendering from a new. Let's look at the outputted video. Oh, now something is broken for me. Took some time. Try again. That works. New video. It's shifted more to up, precisely. And as I've mentioned, if I were to shift it 4 times up, which is from the origin 4 units up, this is precisely half of the screen, and then we would only see the bottom half of our text. I hope, at least. Otherwise, I'm not sure what happens. Let's see. Use the new video. Okay. Yeah. So this moved the text precisely 4 units up, which is half of the screen height. Okay, so we could either now play around and align things ourselves as we would like it, as we would like them to, but that's actually not maybe a very good idea. Let's get to know some other methods. We've seen shift already. Shift actually, wherever the position of the object is, it moves it. It translates it according to the given direction. There's another method which is called move to. Move to is an alternative to shift, and it moves the object to the predefined point. Usually, it takes the center of the object and puts it to a given point. You can, I think, also specify somehow which point of the object it should take. So there you can say, well, take the left edge and put it there, and so on. So that's also possible. But what I actually want to use here, so let me complete this, moves object to given coordinates. What I actually want to use here is t.align2. Align2 uses or with align2 we can align 2 objects to each other somehow, and there's actually some documentation for it if you can look that up, but I'm just going to show you how I want to use it. Namely, I want to say I want to align the text to the bottom of the text should be aligned with the top of the circle. So and the way I do this is I say I align to the circle, and I want to get like the center of one of the edges of the circle, and I take the upmost point, so to say, And from my own object, I want to use the point that's down. So this is the way I have to specify things. This aligns the lower border of my object with the upper border of the circle. So it moves it horizontally to achieve precisely that. Let's comment this out. Shouldn't use too much more in this scene so that you can still see stuff. Maybe I can make this a little smaller. Okay, I render. I didn't save the file, should save it first. Now I render again, sorry. Now let's see what happened. Animation, like this. And precisely what I wanted, namely the lower border of the text is now aligned with the upper border of the circle and then the square. In these cases, I would actually like to see also a little bit of a buffer between the circle and the square, so it should not align perfectly, but maybe we can add a small space. That's also not a problem. We can just chain the methods together and say, well, if you're there, then also shift it 0.1 units up. 0.1 units up precisely. And then render it again. Let's see. Let's just play around a little. See what happened. I'll copy paste this in the shared notes in a moment. Yeah, that's it. So we created a little bit more space, which is, well, we could have actually used a bit more, but that's up to taste, of course. Okay, let me just take all of this. Thank you very much. Thank you so much. Then what else do I want to tell you? Of course, the most important thing almost, we would of course also like to be able to write formulas in a nice way, and well, this is where Manim really shines. Manim uses LaTeX as a rendering backend. Basically, it takes LaTeX code, it renders the DVI, it converts the DVI into an SVG, and then and then takes the SVGs and puts them on the screen. So the rendered vector graphics. And how that works is we use some, let's say, form equals tech. And what do we want to write? Let's maybe put some nice little formula. So actually I want to then use math tech, because then I don't have to care about the dollar signs, so I don't have to care about math mode. I also write it as a raw string because Python and backslashes in strings are a bit of a funny story. So and then I can use like if f is in age of math bbc, then right arrow integral or over something, let's write gamma f of z dz equals 0. So Cauchy's integral theorem. And I should also put it somewhere actually, because now we can see it on the screen. I will write it and maybe also align it. We can say form.align to. This time I want to align it to the lower border of the circle. So let's say circ get edge center, this time the lower center and the upper edge of my own thing, and then shift it down by, let's say, 0.2 units. And now let's write it. Self.play write form. Let's see, hope for the best. So LaTeX, rendering LaTeX of course takes a little bit of time because, well, the file has to be, there's a file that's written and that has to be rendered and called by LaTeX first, but it doesn't take so long. Then again, let's see what happened. Okay, so animation, first one, and there's the formula. Neat. What we could do at this point as well, but that's a bit advanced and I don't really want to go into detail there. We could take parts of the formula, so we can divide it into separate strings, so to say, and then we can access these strings separately. So I could, if I wanted to, move away the first part, the f in h of c. I could move away the right arrow. I could move the integral stuff away. That's all possible, and doesn't really. It's not really that difficult. But again. Yes, thank you. I just saw the. Thank you. So it means with MathTeX, MathTeX, you can render arbitrary LaTeX code. Yes. Arbitrary LaTeX code can be rendered with MathTeX. There is some documentation if you need special packages and stuff. We've made that easier, like a ton compared to the official non-community maintained version of Manim. There has been a lot of work put into that. So you can actually work with custom packages and everything that you want to. Yeah, I suppose. I haven't tried it. For tables and matrices, it's usually easier to revert to capabilities provided by Manim itself. Okay, then I don't actually have that much stuff left. I want to show you and talk about. I see there are some questions happening. Let's wait what happens. So first question, is it possible to animate graphs? Yes, that's possible. It takes it takes a little bit to set up though, so I don't want to show it necessarily in this setting, but let me quickly show you examples. Plotting with Manim. All of these, you can't see, sorry. All of these here are drawn and created by Manim directly. And maybe I can even show you, so all of these were static images now. Let me show you, there is something fancy. This here is fancy, for example. So this also shows you can definitely plot and do things with graphs as well. Another question, could you use ticks inside LaTeX for more complicated shapes? Yes, in theory that's possible. It might be easier though to take the ticks rendered picture and clean it up a little bit in an vector graphics editor. So save the thing that you have, put it into convert it to an SVG and then work with that. It might be easier for Manim to do that. Another question, is it possible to import the animations to already existing LaTeX documents? I'm not sure what you mean by that question. So I'm rendering the videos and then including them in a PDF is the PDF viewer needs to support it, and I think we've seen in multiple occasions over several years that whenever we wanted to have a presentation with videos in it at the department, then well, it didn't work out so great. But in principle, it's possible to include something that's rendered by Manim in a LaTeX in a PDF. The question, however, is how resistant to pain you are, because I feel that it might be a bit of a painful experience to try that. Okay, so the very last thing I do want to show, and then I hand over to the session chair again. The very last thing I want to show is well, I don't want to write the animation in full now because it's actually quite late already. The one thing I would like to show you is a small project which uses a bit a bit more of Python stuff. I'll copy and paste the code in a moment, and then we can maybe have a short look at it. Actually, you can see it already here, and I paste it into the thing. Document. So this is the last thing I want to show you. Small document, small project. So what does it do? I create a set of vertices, which are supposed to be just what Manim calls dots. There's a question maybe. Goodbye, Andreas. Good luck for your dentist appointment. The last thing I want to show, this thing here. So I create a list of vertices. So 10 vertices here that I collect in a so-called V group, which is just a group of objects basically. I arrange these vertices so that they are, if they are created, they are all in one location, and if I use this arrange function of the group, then they are spread across then they are distributed evenly. Then I show an animation which creates all of these vertices basically. Then I create some targets. I choose a random permutation, and then I move the vertices to the new random location and move them a little bit down. So that's what you basically can imagine from this. Let's try to render it and have a look at it, just to give you a feeling of how complex code is that you have to write in order to get something that you might want. Let me see. So this is now a different file, and the animation is called the scene is called small project. Let's render. Now I just have to find it. Videos, this here. Okay. And now I should also show it. So the 10 points are drawn, and then they are a random permutation is chosen, and the points are moved across the screen according to this random permutation. And yeah, I think this illustrates really well that stuff is actually not that complicated if you kind of have an idea of what you want to achieve. In this case, I said, well, I want to illustrate the wiring diagram of a permutation, and well, the code is not that complicated. It's kind of verbose if you know what how to read things. It's kind of tricky though to get to the point where you can say, okay, I need to use that, and that's the easiest solution to follow some direction. That's a bit tough. I completely agree on that. But yeah, that's it from my side. Thanks for watching, and I'm open to answer more questions if there are any.